Did we talk about it? Yeah. So we have the prostate gland here, so that's the prostatic urethra, then the membranous urethra, and then all the urethra that's in the penis is the penile urethra. So that's pretty self-explanatory. Okay, just remember where the external sphincter is. So this is the external sphincter in the man. Of course, the internal sphincter is the same place it is in the female. So right here is the external urethral sphincter. Well, just that section where I have my thumbnail in, just that is the membranous urethra. Okay. If it's in the prostate, it's prostatic urethra. If it's just in that area, it's the membranous urethra. Then the rest of it's the penile urethra. Cool? All right, Kayla, what's the function of the kidney? What's the big picture for the kidneys?
It's like a waste stream. It's like a waste stream. Like,
No, it's to filter all the blood, take all the waste out, secrete that, and absorb all the good stuff. So that's the job of that. So we got to follow all this blood has to go in there. And then we have to have a mechanism for it to filter. All right, so we defined the artery coming in, okay? And remember, every time it branches to a different branch, it changes names, okay? So this one here, this branching here, is going to be the segmental, okay? Then we have between the pyramids is interlobular. Then when you arc around, makes sense, it's the arcuate. And then when you go up and into the cortex, then you're the interlobular, okay? So, but really the only thing you get confused is lobar and lobular, but just make sure you make that distinction. The rest of it is pretty intuitive. All right, so now we're looking at the glomerulus. So this is the afferent coming in. There's your glomerular capillaries, and remember this is dissected. One has the full thing, and then one is dissected of the processes that are on there that we'll talk about a little bit later. Okay, so afferent, then we have the glomerular capillaries, then we have the afferent, and then on which model do we have? This model here, or this model, or the only model. My glomerular arteries, they're jumping me. Okay, so if you're around the nephron, if you're around these things up here in the cortex, you are the peritubular capillaries. If you jump down into the medulla, then you are the vasa recta. Okay, so vasa recta means straight vessels, right? Well, there you go. All right, now let's look at the glomerulus. I love glomerulus. All right, so now we're looking at the nephron, and this is the nephron. Okay, so make sure you understand that all these little things are those things, and this is those things dissected in half. All right, so we're going to use this guy because it's more convenient. All right, so this is the glomerulus. We have the capsule itself is lined with the epithelium. Okay, so this is epithelium. So this is simple squamous epithelium. So I like to ask those kind of questions. So make sure you make note of that that's what it's composed of. Okay, and then the visceral layer is this stuff that's on top of it. Okay, remember, this is the dissected side. So this is the visceral layer right here, not this side. This is just the capillary. And if you look close, can you get close in there? You can see perforations in this one here, okay? Because this one is fenestrated. It's got holes because what's the first function of the kidneys? Filtration. We got to get this thing filtered out, okay? So on this side over here, we see the little blue nuclei. That is the podocyte. Okay? Can you see that? There's a little blue nuclei, so that's the podocyte. Then the little red interdigitations here are an interdigitation from one side interdigitating with the podocyte from the other side, And those are called podocils, okay? So they extend from the podocyte. And so their job is to form a filtration slit, like this. Okay, so that's the outer layer. If we go in, we have a basement membrane, and then we have a fenestrated endothelium, which is shown on here. So this is the fenestrated epithelium that's on there, because we stripped all this off. Cool? Okay, and I brought my old French press, where you saw the different layers, so you can filter it. Well, that's almost exactly the same mechanism that they use for this thing here. Okay, so this thing does not sit in there. It is suspended. Okay, so there's a space, and you can see the space right here. Okay, between the artery and the capsular. So this is the capsular space. Cool? Space, the final frontier.
We didn't let him do the review last time because you were here.
All right. So now,
Oh, yeah.
coming out of here, because this is the tubes that's going to go all crazy next to it. So this is the proximal convoluted tubule. Okay, this is this. Okay, just big and blown up. Okay, so coming right out of the capsule is the proximal convoluted tubule, and it does all its stuff. It's surrounded by peritubular capillary. Then we have the loop of Henle, the thick descending limb, turning into the thin descending limb, turning into the thin ascending limb, turning into the thick ascending limb. And all that's for the concentration gradient, so you can absorb and pull out through osmosis. You can control the water and all that kind of stuff coming in. All right, so here, this area right there is the distal convoluted tubule that's represented by this here. Okay, and this is the mechanism. This is the macula densa is right here, and then this portion of the afferent is called the juxtaglomerular apparatus. Do I have it up there? Oh, we talked about it up in the stuff. So these two talk to each other, okay? The juxtaglomerular cells and the macula densa make up the juxtaglomerular apparatus, which helps regulate arterial blood pressure and filtration by the kidneys. Okay, so we're going to have ADHD aldosterone affect these areas right here. In between, there's mesangial cells that you have to pretend because they're not drawn in. They didn't ask me about making this model, so they didn't do it accurate enough. Cool? All right, so this is all the stuff for the kidney. All right. Let's see.